What's up, guys? Welcome to the video on factors and multiples. Let's do it. First, we're going to talk about multiples. I always like to talk about multiples first because they're a little bit easier to understand. So what is a multiple of something? A multiple of something is simply multiple occurrences of that number. So if we have a multiple of 3, it could be 3, which is just 1 3, 6, which is 2 3s, 9, which is 3 3s, so on and so forth. So let's go through some examples. Like, what's a multiple of 9, right? It's a number created by multiplying 9 and an integer, multiple events of that 9. So for example, 81 is a multiple of 9, simply 9 times 9. 18 is a multiple of 9, it's 9 times 2. And 27, which is 9 times 3. So that's really all there is to it. That is a multiple. Now let's talk about factors. So what is a factor? A factor is any integer that can be divided cleanly into a number, meaning it can be divided in by another integer number of times. So what does that mean? So let's talk about factors of 9, for example. 3 is a factor of 9. Why? Because 9 divided by 3 gives you 3, okay? What about factors of 32, right? So a factor of 32 would be 2, because it can go in 16 times. Another factor of 32 is 8, because that can go in 4 times. So you see, these are all numbers that can be divided cleanly into the starting number. Those are all factors. What is the greatest common factor? This is something that you should absolutely be familiar with. So when somebody's asking for the greatest common factor, it's the largest number that divides into two numbers, into both numbers. Let's take an example. Let's say we have 18 and 24. So first, we're just gonna look at some common factors before we figure out the greatest common factor. So first of all, these are both even numbers. So they're both divisible by 2. 2 is a factor of both. But let's see if we can get something bigger. Well, they can both be divided by 3 as well. 3 is also a factor. So that's larger than 2. So 2 can't be the greatest common factor. But what else? We also have 6. Okay? 6 goes into 18 3 times. 6 goes into 24 4 times. So in this case, 6 is the greatest common factor out of all the 3 common factors. Now I'm going to give you another example of finding the greatest common factor, but for two really big numbers, okay? Because this becomes a little bit more difficult, a little bit more involved. So when we have two big numbers, we're going to have to use something called a prime factorization tree. So let's start. Let's say we have two numbers, 264 and 504. So this is a little bit more involved than simply 24 and 18. So how do we tackle this? Well, I'm going to show you how to make a prime factorization tree. It's really not that bad. So first, when we're making a prime factorization tree, all we're trying to do is we're trying to split these numbers up into factors that we know. And the order doesn't matter. You can do it however you see fit. So I always like to start with even numbers. I recognize that these numbers have to be divisible by 2, so that's easy for me, so I start there. So I can break 264 down into 2 and, well, what times 2 gives me 264? That'd be 132. All right, and then each little branch I break down further if I can. If I can't, like for example that 2, which is a prime number, I can't break it down into factors, so I just leave it as is and I'm done there. But what about the 132? It's even again, so I'm going to go ahead and split that into 2 and, well, what times 2 is 132? That's 66. Break the 66 up again into 2 and 33. What about that 33? Well, I know 33 is divisible by 3. And what times 3 is 33? That is 11. And you notice here I'm circling all the numbers that can't be broken down, like 2, 2, 2, 3. Those are all prime numbers. So I circle those to indicate that I'm done. And what about 11 there? 11 is also a prime number. So guess what? This is why it's called a prime factorization tree. Once we have only prime numbers at the ends, we are done. Now let's repeat the same process with 504. So first again, I'm going to split it into 2 and 252. Circle that 2. Let's split it again to 2 and 126, because 2 times 126 would bring us back to 252. Let's take 126, same thing, we divide it by 2 and we get 2 and 63. Finally, 63 can be broken up into 7 and 9. Actually, we can go one level further. So now we got 7 there, and what about that 9? It can be broken up into 3 times 3. Now we've got all prime numbers for both. Okay, so how does this help us find the greatest common factor? This is the really cool part. So now all we do is we look at what are the common prime numbers across these trees. So we're gonna highlight them one at a time. First, I see a set of 2's that are common. I see another set of 2's that are common. I see a third set of 2's that are common. And finally, I see one set of 3's that are common. So now I've highlighted all the common pieces. So now all we do is we take those pieces, just one side of them, and we multiply them together. So we take 2 times 2 times 2 times 3. What does that give us? That gives us 24. And guess what? That is our greatest common factor. So believe it or not, once you get comfortable with this method, it's actually much faster than trying to guess and check and figure out a greatest common factor. Plus, this is super accurate. You're not gonna make a mistake if you do it this way. That's all for the video on factors and multiples. Let's get into some practice problems.